Okay, hi everyone, welcome back. It's Professor Sebastian. We're working on our statistics class notes. We're on page 55 now, and we're actually going to go ahead and use StatCrunch to find the regression equation. So to find the regression equation using technology, in our case StatCrunch, we're going to follow the same steps as we did for finding the correlation coefficient. So I really didn't point it out before, but the regression equation was on those results. So example 67, here we have a table showing the heights and weights for 6 people. Find the regression equation that describes the relationship between height and weight. Okay, so first we're going to plot the data in StatCrunch to verify that this data follows a linear trend. We should always do that. If it doesn't follow a linear trend, then all of this is malarkey. It's not real stats. It doesn't mean anything if we don't have a linear trend. Okay, so really this is, I've already told you how to do this, so let me just go show you. But you choose stat button, then regression, then simple linear. Make sure you got the x variable, and now I printed out the x variable being height, right? Remember, dependent is y, independent is x. So I got to remember to put x variable height and the y variable is weight, and then just hit compute. The next thing that comes out will be the regression equation, and always in the form of y equals b plus mx, the equation for the regression line, I should say. Okay, so let's go over there to StatCrunch and check this out. The wrong thing. Here's StatCrunch. Okay, whoops, got the data here. Nope, need to get the right data. Let's go to, okay, I thought this was it, right? Maybe it was the right data. Yeah, this is the right data, height and weights. Okay, we're going to make height x. So we're going to go stat, regression, simple linear. Okay, we got to make sure we choose the right x that we want, in this case x. We're always going to use x to predict y, so it's important you know what you're choosing to be x. It wouldn't matter for the correlation coefficient, but it matters very much what you make x when you're trying to look at the regression line equation. So we use x to be height, so y is weight. Okay, and then we'll just hit compute. And here's our results. Okay, so these are the results that I've cut and pasted. Oh, slightly different. Sorry, then I cut and pasted. I must have changed the value. Let's see, what value did I change? Let's go look. It's slightly different than I have in my notes. I must have. So I got 61, 104, 61, 110. Is that right? Oh, I got 62, 210. I typed something in different. So let me go back and fix this. 62. I put it in there wrong. Hopefully that's it. Let's go ahead and run it again. There we go. That's what I have cut and pasted into your notes right here. Okay, so now when I go back to the notes, just what I had right there, I just cut and pasted. So again, this third line, first it says the y variable, then it says the x variable, calls them dependent and independent, and then it gives the regression equation, which is always in the form of y equals b plus mx. M is the slope, b is the y-intercept. So let's use the equation of that regression line, which is this. I just retyped it here. I just said let's do 3 decimals when I retyped it. Whatever decimals you want to use or are told to use by my stat lab is fine. So I'm going to use it to predict the weight of a person who is 65 inches tall. That means you put in the height of 65 right there. Plug this into your calculator, minus 442.882 plus 9.029 times 65. And you get 144.003 pounds. Remember, order of operations, do the multiplication first before you subtract that. So if someone were 65 inches tall, that would predict, based on the data set of those 6 people, that that person would be 144 pounds. Okay, please remember, order matters. I've tried to say it many times, but whatever you put in for x is trying to predict what y is. If you want to predict a certain thing, if you want to predict weight using height to predict it, then height needs to be the x variable. Because of that, sometimes instead of calling x the independent variable and y the dependent variable, there are other names. Sometimes people call x the predictor variable because it's trying to predict y, so y is the predicted variable. Another name that's common is the x is the explanatory variable because it's trying to explain the response that you get with y, where y is the response variable. Okay, I'll come back on the next video and do this next example.